Good morning all. Today we are going to discuss indexing in DBMS. Optimize the performance of database, that is reducing number of disk access required when a query is processing. Index is a type of data structure. It is used to locate and access the data in a database table quickly. The index structure. The index can be created using some database columns. The structure will be as like the first column of the database is a search key. It may be contains the primary key or maybe the candidate key of the table. The second column of the database is the data reference. So contains set of pointers holding the address of the disk block where the value of the particular key can be found. Indexing methods. Ordered indices. The indices normally will be in a sorted order in order to make searching faster. For example, suppose we have an employee table with thousands of records and each of which is 10 bytes long. If their ID start with 1, 2, 3 and so on, we have to search student with ID 543. In case there is no index, we have to search disk block from starting to till the end. That means after reading that 543 into 10, 5430 bytes. In case of an index, we will search using indexes and the DBMS will read the record after reading 542 into 2. That means 1084 bytes, which are very less compared to the previous case. Next one, we are going to discuss primary index. Index created on the basis of primary key of the table, then it is known as primary indexing. These indexing are unique to each record and contain one-to-one relationship between records. As primary keys are stored in a sorted order, the performance of searching is efficient. The primary index can be classified into two types. One is the dense index, the other is the sparse index. Now we are going to discuss dense index. It contains a record for every search key value in the data file. In this, number of records in the index table is same as the number of records in the main table. It needs more space so that it can save the index also. See, for example, index table having a UP keyword, the same value there in the main table also UP, like USA, Nepal will be there, right? This is the dense index. Next one is a sparse index. In that data file, index records appear only for a few items, not for all the data items. Each item points to a block. In this, instead of pointing to each record in the main table, the index points to the records in the main table in a gap. See, for example, UP having the index record, but whereas USA does not have. Whereas Nepal having the Nepal record, UK having the UK. Next one, clustering index. A clustered index defined as an ordered data file. The index created on non-primary key columns, which may not unique for each record. It may be sometimes it may be the primary key also. In this case, to identify a record faster, we will group two or more columns to get the unique value and create an index. This method is called as a clustering index. The records which have a similar characteristics are grouped and indices are created for these groups. Clustering index example. See here, department ID and pointer will be given. So correspondingly, main table having the records. A company contains several employees in each department. In a clustering index, where all employees which belong to the same department ID are considered as a single cluster. For example, department ID 1 will be the single cluster, 2 is a single cluster, 3 is a single cluster, like that. Here the department ID is a non-unique. instead of previous scheme, maybe the little confusing. One disk block is shared by records which belong to the different cluster in the previous scheme, whereas if you use a separate disk block for separate clusters, then known as better technique. The next one, secondary index. In the sparse indexing, size of table grows, size of mapping also grows. So these mappings usually kept in primary memory, so address fetch should be faster. Then the secondary memory searches the actual data based on the address got from the mapping. So if the mapping size grows, then fetching the address itself becomes slower. In this case, the sparse index will not be efficient. In order to overcome this problem, we are going for the secondary indexing method. Here, to reduce the size of mapping, another level indexing is introduced. In this method, a huge range of for the columns is selected initially, so that the mapping of size of the first level becomes small. Then each range is further divided into smaller ranges. The mapping of the first level is stored in the primary memory, so that address fetch is faster. The mapping of the second level and the actual data are stored in the secondary memory, maybe in the address. See the example. To find the record roll number 111 in the diagram, then it will search the highest entry which is smaller than or equal to 111 in the first level index, that means the 100. Then it will search in the second index level. Again it is the maximum is 111 and it gets 110. So now using the address 110, it goes to the data block and starts searching each record till it gets 111. In same way, the inserting, updating and deleting also in the same manner. Thank you.